Good day, grade 12 learners. Welcome to today's mathematics lesson. My name is Annelen Sindane. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Now, I hope we are ready for today's lesson. We're still continuing with functions. Last week, we looked at the revision of grade 11 functions, together with the interpretation of our functions and solving problems that involve lots of interpretation. Today we are going to look at something new that we have only covered in grade 12 now. So the topic is still functions, and please be reminded that functions contribute about 35 plus minus 3 marks. It's a lot of marks. And today we are looking at inverse functions, and they contribute about 10 plus minus 3 marks in our final examination paper. And at the end of the lesson today, we should be able to understand, sketch, and interpret functions and their inverses. And we are going to look at the inverse functions of the functions of the quadratic function, linear function, as well as the exponential function. But for today's lesson, we are only going to focus on the linear function as well as the quadratic function. Now, we are going to look at aspects that we have also looked at in the previous lessons: how to get our intercepts with the axis, how to get the axis of symmetry, how to determine and interpret the domain and range of our functions that we are going to look at. We also look at the turning points for those functions that have turning points. We also look at the notation that we use to represent our domain and range using the interval notation. You are aware that this means it's less than x less than whatever is the other endpoint. We separate our terms using the semicolon, and we are using either x element or we are using y element, depending on whether we are dealing with the values of x or the values of y. So this one, it's not including the endpoints. Then we have this other one where we are including our endpoints. It's less than or equal to, less than or equal to. We also have where you have the left-hand side not being included and the right-hand side of the endpoint being included. And also we have that one as well, where we have to represent the interval of the values that we want to represent. Now, we have to also understand basic graphs that we have looked at: our linear function, quadratic function, our exponential function, as well as our hyperbolic function. But for the inverse function, we are not going to look at the hyperbolic function. We can refer to our CAPS document on page 32, as well as the revised examination guidelines that were released in 2021, so that we are able to see what is going to be examined there under the topic. Now, our pre-knowledge, what we already know, and the skills that we will need in order to help us get this. We are going to be sketching straight line functions, quadratic functions with one or more parameters using the dual intercept method. Remember, others are taught to use the table, but it might take some bit of time. Hence, we are using the dual intercept method, which is a bit faster and saves us time in the exam versus the table. We want to look at the effect of the parameters A, P, and q. Remember, for our functions, if we are dealing with a quadratic function, we have f of x is equal to ax plus p squared plus q. So we want to look at the effect of these parameters a, p, and q in our functions. This is an example. For our linear function, we can write it as f of x is equal to ax plus q. You have discussed what is the effect of a, what does a contribute to the function, what does q contribute to the function. We also have to determine the domain and range of these functions. How do you determine the domain? We'll go back to the basic. Our domain, we know that it is the x values where our function is defined, and our range, these are our y values where our function is defined. We are also going to be solving equations, and algebra is very important here, because when we are dealing with functions, mostly finding x-intercepts, you are solving equations, finding y-intercept, substituting and getting your y-intercept, and so on. So we need our algebra to be good. We'll be changing subject of the formula. We have been doing this since grade 9. We move on now. So we are going to determine and sketch the inverse functions defined by. The first one, it's going to be our linear function. The second one is going to be our quadratic function. You can see now that we are not going to be looking at the complicated quadratic function. It's just ax squared. And then the exponential function, we are not going to deal with it this week, but we will deal with it next week. So for today, it's these two. Now, I want us to define a function using mathematics. We started doing functions in grade 8 using our flow diagrams, and we are continuing with the definition of a function even in grade 12. You will find out that some of the relations that we have been dealing with, we have been calling them functions, but you will find out that today the definition of a function takes another dimension, as we are referring to functions. A function is a relation in which for every x value in the domain is associated with only, let's underline there, only one y value in the range. Now, we also know that we have different types of functions. We have a one-to-one function. I will show you the illustrations as we move along, where for every x value in the domain, it is associated with only one y value in the range. And every y value in the range, it's also associated with only one y value in the domain. So now, this is a two-way process. One x value, one y value that is mapped into the range. So that's a one-to-one function. Then we know that for a function to have an inverse, which is also a function, it has to be a one-to-one function. So if a function is not one-to-one, then its inverse will not be a function. These are the kind of questions that are liked under this topic. You'll be given a sketch and you might be asked, is this function a function? Give reasons for your answer. So we will discuss ways of how to determine whether a function is one-to-one or not, as well as to determine whether if it's a function, we have to determine whether it's one-to-one or not, using the horizontal and the vertical line test to help us deduce whether our function is one-to-one or not. If a function is one-to-one, it follows that its inverse will also be a function, only if it is a one-to-one function. Let's move on. Now, this is what we are going to use to help us understand this concept of a one-to-one function, many-to-one function, and a one-to-many function, so that we are able to distinguish and we are able to identify the type of a function that we are working with as we move along. Right. A one-to-one function, what I have here are ordered pairs where we have our x and y values. So -2, when our x is -2, our y is 1. When our x is 4, our y is 6. When our x is 5, our y is 7. And when our x is 3, our y is 9. You realize that there are no similar x values or there are no similar y values. Each x value in our domain, it's only having one corresponding y value in the range. This is illustrated in the diagram below. -2 goes with 1, 4 goes with 6, 5 goes with 7, and 3 goes with 9. Then we are able to deduce that this is a one-to-one function because every x value in the domain is associated with only one y value in the range. Remember, how can we do this? For every x value in the domain, it is associated with only one value there. Remember, to get our y value, we substitute the x value in the domain into a function and the output gives us the y value in our range, which is our f of x there. We move on. If we have two elements in the domain that associate with the same element in the range, the relation is called a many-to-one relation or function. Now, here is the illustration. -2, when x is -2, our y is 16. When x is 0, our y is 4. When x is 1, our y is 4. There is an abnormality there. We are having two x values that are associated with only one y value there. Hence, it's a many-to-one. When our x is 0, our y is 4. When our x is 1, our y is also 4. So both different x values are associating with one y value. Hence, it's a many-to-one. If you check 3, it associated with 7. It has only one y value there. And to illustrate this using arrows and the mapping, you are able to see that each x value, this -2, is associated with 16. But here is where we have two x values that are associated to only one y value. Hence, it's called a many-to-one. 3 is only associated with 1, 7 there. So this is a many-to-one, not a one-to-one. Many-to-one. We move on to the next one. If we have an x value in the domain that associates with more than one y values again, we are going to have a one-to-many. Let's check and see. If you check, we have coordinates -2 and 16. We have 4 and 1. we also have 4 and 6. If you check on this one, I have a 4, on that one I have a 4, but they are mapping to different values of y, hence it becomes a many to 1. You are having different x values that are associating to, you have one x value that is associating to different y values. So it's a 1 to many. 4 has another y value which is 1 and another y value which is 6. So it's a 1 to many. And if it is a 1 to many, then we say this is not a function, but a relation. It's not a function. Using our mathematical definition of a function, where we are using domain and range. We move on, and I want us to illustrate this using graphs. If you check the first graph, it's an increasing linear function, and you are able to see that for each x value there is only one y value. You are able to see x1 goes with y1. You can associate this different x will have a different y value. No two points are having the same x value or the same y value there. And then we have a graph. If you can tell me the type of a function that graph represents, I know you know it. Yes, it's a parabola or a quadratic function, which is concave up. You are able to see that if I have x1 and x2, for example, if I have the equation y is equal to x squared, when I substitute my x as -1, I will have y as -1 squared. And this will give me 1. I also have y is equal to, my x2 is +1, -1, like that. I will have 1 squared, which also gives me 1 as the y value there. So you can see that this is a many to 1, different x values, -1 and +1. They are all giving the same y value, which is 1. So it's a many to 1. It's a function. It's a function. Now, but if we look at the third graph there, you can say it's the graph of the parabola, which is reflected about a certain angle. It's rotated about 90 degrees. You are able to see that you are having an x value that has different y values. This is a 1 to many. And we said a 1 to many is not a function. So this will not be a function, because you are having one x value that is associated with different y values in the range. So this will not be a function. Now, you are able to see that the inverse of a many to 1 function is not a function. So we are able to see that the inverse of this one, yes, it is a function, but its inverse will not be a function. You are going to get the explanation just now. So there was need to always restrict the domain so that the function becomes a 1-to-1 function before we are able to determine its inverse function, because its inverse will not be a function. Let's move on and get illustrations of this. Now, remember, the range of the original function is always preserved. Now, we are going to talk a lot about the domain and range, and we are going to look at how we can restrict the domain so that whatever we have as a function is a one-to-one function, so that the inverse that we get is also a function. How do we test for inverse functions? We use the vertical line test and the horizontal line test. Now, the explanation is above, but what you can do, you just take a straight ruler, or you can have a transparent paper if you have, move it from left to right to whatever you are given as a graph. If it intersects at any given point more than one part of the graph, then it means it's not a function. Like you are able to see that one. At any given point, this is a circle. The moment you have a ruler intersecting there and there, it's 2 points. This will not be a function. Let's look at a hyperbola as an example. A hyperbola is a function, as you can see. As you move from left to right, the ruler can only intersect that part of the hyperbola at any given time, and it cannot intersect any two given points. There's an asymptote there, and we know that in an asymptote our graph is not defined. And if you have that other arm of our hyperbola, you are able to see that the ruler will only intersect one part at any given time. It can't intersect two parts of that hyperbola twice at any given moment. It will only intersect it once, so this is a function. There we have the graph of that. It looks like a parabola from what we know. You are able to see that the ruler intersects two parts of this graph at any given time. So it means when we have a parabola on the x-axis, it means it's not a function. Remember, we said this was not a function because it's a one-to-many relation. We move on now. The test that we are going to do now, you are using the vertical line test to determine whether whatever we are given is a function. If it's a sketched one, you want to determine whether it's a function or not. If you are certain that is a function, we now do the horizontal line test to check if it is a one-to-one function. Now, how do we do that? Now, we place our ruler horizontal, and we want to check if it will intersect the graph at any given time at two or more points at the same time. Yes. If we are having a graph like that, when you do your horizontal line test, you are placing your ruler horizontal like that, or you draw a straight line like that. If it intersects the graph at 2 points at the same time, then it is not a one-to-one function. So for this one, it's a one-to-one function because it passes the horizontal line test. We have another parabola there. You are able to see that this will pass the vertical line test because the ruler will only intersect the graph at only 1 point. It is a function. But if you do the horizontal line test, you are able to see that at any given time, the line is intersecting at two different points. Hence, this is not a one-to-one function. It is a function which is a many-to-one function. But the inverse of this function will not be a function because it is not a one-to-one function. Hence, we are supposed to do a restriction on the domain so that we only work with one half of the parabola hence it becomes a one-to-one function, so that the inverse is also a function. We move on. That one, it fails both the vertical line test and the horizontal line test. It is not a function. So because it is not a function, it can never be a one-to-one function. We move along. Now, let's look at the notation for our inverse function. We know that for our functions, we use f of x, we use g of x, we use h of x, we use our k of x, any letter of the alphabet followed by x. That's how we represent our functions. Now, the inverse of f of x will become f inverse x, of g of x is g inverse x, of h of x is h inverse x, k inverse x. It's k, it's f to the exponent -1. That's how we name our inverse functions. Now, I know mathematically when someone says an inverse, people think of the reciprocal. They are not the same. Inverse, it is the reflection of a function along the line y is equal to x, and the notation is f inverse x. If you check there, the inverse is what we are explaining there. 1 over f of x is the reciprocal of f of x. It is not the inverse. So let's take note. F inverse x means the inverse of f of x. So let's not mix up the notation. Now, the inverse is the reflection of the function f of x along the line y is equal to x. Always, that's the definition of an inverse. Now, we move on. We are going to look at steps of how we get the equation of an inverse function, so that once we get the equation, if you are given one of the functions, you are able to sketch both of them on the same set of axes. For example, if you are given y is equal to 4x plus 5, for us to get the inverse function, we interchange x and y. We had y here, now we have x. We had x here, now we have y. We have interchanged. But remember, we make y the subject so that our equation is also y equals. Changing the subject of the formula, which we did, and we get the inverse function will have the equation y is equal to 1 over 4 x minus 5 over 4. This is the inverse function of a linear function. For the quadratic function, you have your y is equal to 2x squared. You swap x and y positions, and you will get where there was y, we now have x. Where we had x, we now have y. But remember, we have to make y the subject, in which case we will have y squared is equal to x over 2. So to make y the subject, remember this is y is equal to plus or minus the square root of x over 2 there. But now, remember, when we get this inverse, it is not a function, because the original function y is equal to 2x squared, it's a many to 1. So its inverse per se will not be a one-to-one function. Hence, its inverse that you get from this function with plus or minus will not be a one-to-one function. We move on. Now, how do we sketch the inverse function? Draw the given function. You draw the reflection line, y is equal to x, using the dotted lines. We then take any 2 points that are given in the function. We interchange the x and y values and then plot the 2 new points. Now, you draw the graph by joining the points that you have plotted and you reflect them along the line y is equal to x, our mirror line or our reflection line. Let's look at an example. I know I've been talking for too long. Quickly, if I can ask you for 2 minutes, you determine the equation of f inverse x in the form y is equal to x, given that our f of x is equal to 4x plus 4. Remember the process. You write in place of f of x, you use y equals. Step 1, you interchange x and y, and then you make y the subject. Your 2 minutes start now. Welcome back. I hope you have managed to get the inverse function. So now, remember we said the steps where there's f of x, we replace with y and write 4x plus 4. The next step, we interchange x and y. So this becomes x is equal to, where there was y, I'm now putting x, and where there was x, I'm putting y, 4y plus 4. The left-hand side is equal to the right-hand side. I will move 4 to the other side. This becomes x minus 4 is equal to 4y. If I write this as 4y is equal to x minus 4, I haven't changed the equation. What was on the left-hand side, I've written on the right-hand side. I still have my left-hand side and my right-hand side, and they are equal. I can position them anywhere. Next step, I want y to be the subject. The coefficient of y is 4. I will divide both sides of the equation by 4, and get my equation as y is equal to x minus 4 over 4. Or I can write this as y is equal to 1 over 4x, negative 4 divided by 4 minus 1. That's my equation. I will get, depending on the examiner, this will be 2 marks. Swapping x and y normally has a mark, and making y the subject also gives us the second mark there. We move on. 1.2 requires us to sketch. 1.2 requires us to sketch the graph of f and f inverse on the same set of axes, and we have to show the line of symmetry. Let's quickly do that. Now, in order for us to do a sketch, we know that we need our x-intercepts and our y-intercepts. How many functions are we having? We are having our f of x equal to 4x plus 4, and we are having f inverse x, which is equal to x minus 4 over 4. That's our f of x inverse. Now, our x-intercept, we know that we let our f of x to be equal to 0, and we are solving 4x plus 4 is equal to 0, and we will get our 4x is equal to negative 4. We get our x as negative 1. So for f of x, our x-intercept is going to be negative 0. Our y-intercept, we let our x to be equal to 0. So we are evaluating f of 0. 4 times 0 plus 4. We know that f of 0 is equal to 4. So we have 0 and 4. If we check, our a is equal to 4, meaning our a is greater than 0. It means our function is an increasing function, like that, because our gradient is positive. Let's move on to our f inverse. So for our inverse, to get our x-intercept, we let this to be equal to 0, and we will have 0 is equal to x minus 4 over 4. This will give our x minus 4 is equal to 0, meaning our x is equal to 4. And then this will give our x-intercept as 4 and 0. To find our y-intercept, our x is equal to 0. So f inverse of 0, we are going to have 0 minus 4 over 4, giving us negative 1, which means our y-intercept is going to be 0 and negative 1. There. Also, if I look at this one, my a, you saw that I wrote my f inverse x as 1 over 4x minus 1. You can write it that way. It also agrees. You can see that our q is negative 1, which means our y-intercept is correct there. Our a is equal to 1 over 4, meaning our a is also greater than 0, which means our function is also an increasing function. I will now draw my Cartesian plane, and remember, do not put too many values on your Cartesian plane, otherwise it will give you a challenge there. And if I check, my domain is not restricted, so my graph should show that they continue. They are not stopping there. You put arrows on your graph. So I will have For my f of x, I have my 0 and 4 there. I also have my -1 and 0 there. Plot the 2 points, join using a straight line. I also draw my axis of symmetry given by y is equal to x. I then draw the graph of f inverse using the dual intercept method. I have my x-intercept. I also have my y-intercept. I join the two, and then using a ruler, I join the two. Then I have my f of x as well as my f inverse functions drawn. And you are able to see that they intersect somewhere along the line y is equal to x. Now, that's my graph. In most cases, you will find for finding your x-intercept, your y-intercept, you will get 1 mark. For sketching the first graph, correct shape, your x and the y-intercept, you get a mark. For sketching the other one, you will get 1 or 2 marks. And then our axis of symmetry, and then we get our graph. It might be 3 marks, but for the calculations, remember there is also a method mark and the coordinates that we get there, we get a mark. We sketch the two graphs on the same set of axes. You are able to see that something is happening here. If I look at my f of x, my y-intercept was 0 and 4. My x-intercept is -1 and 0. If I look at, let's look at this, f of x, f inverse of x. Let's look at our x-intercept. What was the x-intercept? We had -1 and 0. For f inverse x, our x-intercept is now our 4 and 0. Let's look at the y-intercept. Okay, something happened there. We will discuss it a bit later. Let me do this. Let's answer 1.3 first. I will do the summary at the end. It says determine the coordinates of the point of intersection between f and f inverse. We have the equations. That's our f. Our f inverse x, we got the equation as x minus 4 over 4. Remember, for us to get the point of intersection, we can equate the two functions. Our f of x is equal to f inverse x. Using the equations, our f of x is 4x plus 4 is equal to x minus 4 over 4. This as a fraction, I can write it over 1. We can cross multiply and we get 4. 4x plus 4 is equal to x minus 4. This is multiplied by 1. So this multiplies that. This multiplies that. 4 times 4x, I will get 16x plus 16 is equal to x minus 4. Then from here, this goes to this 16 goes that side, this x comes this side, I'll remain with 15x is equal to -20. Coefficient of x is 15, divide both sides by 15, and this will give my x as -4 over 3. I will now take this -4 over 3 and substitute it back to the function, and I will get my y as 4 times -4 over 3 plus 4. And this will give me y is equal to -16 over 3 plus 4. And You can use your calculator there. It will give us our y as negative 4 over 3. Meaning the coordinates of the point of intersection here will be our x value. We got negative 4 over 3 there. And our y value is also negative 4 over 3. So the coordinates of this point of intersection here will be negative 4 over 3 and negative 4 over 3. That's how we get the point of intersection. There's another method that we can use to get the point of intersection. We can use simultaneous equations as we did on the first method, but now remember we are having this equation for the axis of symmetry, our reflection line, y is equal to x. We can use it as well. This is our equation 1, and that one is our equation 2. You solve them simultaneously. So where there is y, we are going to substitute with x, and we get 4x plus 4 is equal to x. We get 3x is equal to negative 4, and then we get our x as negative 4 over 3. But remember, our y is equal to x, so we substitute it there. We get our y value as negative 4 over 3, and the coordinates of the point of intersection will still be negative 4 over 3 and negative 4 over 3. I hope this is easy stuff. We move on. Now, let's look at the inverse, the observations that we had. If you check the two graphs, we had the coordinates there. This is the summary I wanted to make earlier on, where you will see that whatever is a y-intercept on the graph of f becomes the x-intercept on the graph of f inverse. I had 0 and 4 here. I have negative 1 and 0 there. Here I now have 4 and 0. The table I was making, I said f of x, we had our x-intercept, it's x-intercept and y-intercept. We said for f of x, our x-intercept was negative 1 and 0. Our y-intercept was 0 and 4. For f inverse x, we had our x-intercept as 4 and 0, and our y-intercept as, we got it as 0 and negative 1. So this is what we see now. The graph is symmetrical about the line. The distance from here to that line and the distance to that line is the same, symmetrical. Take any 2 points on this graph and that one, they will always be equal distance from our dotted line. So you also observed that the x-intercept of f and the y-intercept of f inverse have the same value. There is our x-intercept for our f and our y-intercept, but we are having the values swapped around. Here we had negative 1 and 0. Here we have 0 and negative 1. Same values changing positions. Now, also you know that the y-intercept is the same. The x-intercept, we had our y-intercept for f of x was 0 and 4. The y-intercept for f inverse is 4 and 0, which becomes our x-intercept in this case. They swap positions. What was our y value here has become our x value here. What was our x value here has become our y value here. They swap positions. This is going to be the norm for our functions except for the increasing exponential function that we are going to discuss next week. Let's move on now. Let's look at the inverse of a quadratic function. We mentioned that a quadratic function is a many-to-one function. Therefore, its inverse will not be a function. Hence, we need to restrict the domain so that we have a function. Let's look at this one. Now, see, if you are having a concave up parabola with solid lines and the dotted lines is the inverse, you are able to see that this dotted line, because it does not pass the vertical line test, is not a function. Therefore, we need to restrict. How do we restrict the domain? You only deal with half of the parabola from 0 up to there. This part on the right is not there. How do you restrict? You are taking the part where our x, from here to there, we know that our x values are less than 0, but our y values are greater than 0. And if you check the inverse, will be a function, because once you restrict, you have a one-to-one function, which is this piece of the parabola, and the inverse of this is a reflection about the line y is equal to x, will also be a function with its restrictions. We move on. Let's restrict the domain. Now, we are restricting the domain for x greater than 0. This is no longer there now. We are only dealing with this half from here to there. This is the arm of the parabola that we are dealing with. Our x is greater or equal to 0 and our y is greater than or equal to 0. And you will find that our inverse function will be written, will be sketched and drawn as such. Moving forward, I know it's too hot and you are getting tired. Just 2 minutes. Remember the steps. Determine the equation of F inverse in the form y equals. Remember the steps. You interchange. Where there's f of x, you write y equals 3x for this one. And then you interchange x and y and you make y the subject. Let's calculate. Let's determine the equation of F inverse. 2 minutes. Let's determine the equation of F inverse using the steps that we have highlighted before. Welcome back. I hope it was an easy task to do. Now, I said for us to determine the inverse, we are saying y is equal to 3x squared, step 1. Step 2, you interchange x and y, meaning this, where there is y, we put x, and where there is x, we put y. After that, we said we make y the subject. So the coefficient of y squared is 3. We divide both sides by 3 and we get y squared is equal to x over 3. How do we solve an equation with y squared? Our y is equal to plus or minus the square root of x over 3. But remember what I said. This, when we sketch this function, it will be a one to many and it will not be a function. Restrictions are important, but for the purposes of illustration, we will just use this one, and then you will see as we move along how we use these restrictions. So there you'll get your 2 marks, interchanging x and y, the first mark, and writing it as plus minus the square root of x over 3 there. Now, 1.2, we are supposed to do the sketch, and 1.3, we are supposed to determine the coordinates of the points of intersection between f and f inverse. Let's check. This is what we just did. Interchanged x and y and made y the subject, and we got that one as y is equal to plus or minus the square root of x over 3. But remember, we said this inverse will not be a function because it's a one to many. Let's move along. We're supposed to do the sketch. For us to do the sketch, remember we said our f of x is equal to 3x squared. Our a is greater than 0, meaning the shape of our graph will be concave up. To get our x-intercepts, we let our f of x to be equals to 0, and we know that our x and y-intercept for this one, because it's not translated, we have been doing this since grade 8, we know that our x-intercept is going to be 0 and 0. Our y-intercept is also going to be 0 and 0. Now, our shape is concave up. What you can do, you can substitute f of negative 1 to just check. It will be 3 times negative 1 squared, giving us 3. Our f of 1 will also be 3 times positive 1 squared, giving us 3. You see what we meant? You are having two different x values that are giving us the same y value. This is a many to 1. The inverse of a many to 1 will not be a function because of that. Hence, we'll need to do the restrictions, but for the purposes of sketching, we are able to sketch. So it means we are having our graph as having the coordinates. Somewhere we have negative 1 and 3. We also have 1 and 3. We are able to sketch. We have our turning point, which is also our x and y, which is our x and y intercept, and we have the shape. Our graph is concave up. Let's look at the inverse function. Remember what we indicated. Whatever is our x value on f inverse, we interchange our x and y. So for our f inverse of x, we know that the x-intercept, whatever was our y-intercept becomes our x-intercept. It will still be 0, 0. Also, our turning point will also be 0 and 0. This point, which had x as 3, it's now 3 and negative 1. And the other point will now have 3 and positive 1. So we are now able to sketch our graph using these 2 points. We are having our turning point. We are having 2 points that we can plot, and the shape of the graph comes out. Let's check that part. Now, try to sketch this on your book. I will be with you shortly. There's a technical glitch.
I want you to ask yourself these 3 questions. Number 1, what do I want? Do I want to become an A student, or do I want to become an average student? Number 2, I want you to ask yourself, how do you plan on getting there? Are you going to put more extra hours, or are you going to just sleep? Number 3, who will be with you in this journey? Because it is important that we associate ourselves with students who have the same vision as us, who want to become a student, who want to put in the extra work, who want to become better at what they do. Unsuccessful people do not plan. They just let life happen to them. But successful people are planning on how they want their lives to be. And right now, you plan on how you want your results at the end of the year to be like. The road to success is to commit to yourself. In order for you to become who you want to become as a student, you need to commit to reading your books, to studying, to bettering yourself. I know it's not going to be easy. Actually, no one said it's going to be easy. But if you put in the work, the results will show in your life. Tap into your power. Sometimes you will feel like putting away your books, and not reading as much as you're supposed to be. But I want you to commit, because through commitment, there is infinite power.
Welcome back. I hope you have managed to do your sketch, and your graph should look something like that. Now, remember, our graph is continuing because it does not have a restricted domain and a restricted range. It will continue like that. So our axis of symmetry is there. Our graphs are going to intersect at 2 different points. And I know I've let the cat out of the bag, because the next question is asking us to find the coordinates of the points of intersection. But what's important is how to get them and not to just see them there. Let's move on now and answer 1.3. we are supposed to determine the coordinates of the point of intersection between F and F inverse. Now, remember on the previous one, I showed you two methods. I had a reason to give you the two methods because if you look now, we found our f of x as 3x squared, and we found our f inverse x, we found it as plus minus the square root of x over 3. Now, if in this case you equate f of x is equal to f inverse of x, you are having 3x squared is equal to plus minus the square root of x over 3. You are now solving a said equation, and remember what happens with a said equation. You square both sides. You square on the left, you square on the right. Are you able to see that you are going to have power 4, and we have not yet solved equations with power 4? Hence, we are going to use the second method that I used when we were finding the points of intersection for our linear function. So let's do that. So we are going to use f of x is equal to 3x squared, and we are also going to use y is equal to x there. And when we solve the two equations, we substitute for y and we put x there, and we are going to write that equation in standard form: ax squared plus bx plus c is equal to 0. Then we are going to get x using factorization, x bracket 3x minus 1, and we get our x as 0 and our y as 1 over 3. Using y is equal to x, we are going to get our y as 0, and we are also going to get our x as 1 over 3, giving us our points of intersection as 0, 0, as well as 1 over 3 and 1 over 3. Now, we have answered question 1.3. I know our questions did not give us much of restrictions, but next week when we are looking at the exponential form, we are going to deal with all those that have restrictions so that we see how we restrict our domain and how we get a restricted range. So we move on now. Please, we read the question and understand the information before looking at the questions. There is always a statement that is given there. Let us not jump into answering questions without reading all the information that you are given there. We analyze the diagram or the information. We look for the information in the diagram that can be helpful. We can use color to mark areas or regions where you have implied information. We add it to the diagram. We brainstorm and develop our rough solution, linking the information we are acquiring as we are looking at the question. Then we write a formal solution. I will give us 6 minutes to do activity 1. Let us answer activity 1. Welcome back. I hope you enjoyed answering this question. So the first part, it says write down the coordinates of B. There is our point B. Remember, we read all the information. The graph of G of X, this is our G. This is our G inverse. There is the label on the graph. It says D and B are the X and the Y intercepts of G respectively. C is the x-intercept of G inverse. The graphs of G and G inverse intersect at A. Now, we are supposed to write down the coordinates of B. If you check, B is the y-intercept of G of X, and you are able to see that it is going to be G of 0. You put 0 there, so our G of 0 is going to be 6, and we get our coordinates of B as 0 and 6. Write down. Even if you do not show working, you will get your full marks there, but you must know how to get them. The equation of G inverse, that's how we got our y is equal to 6. So the y coordinate at B is going to be 6. We move on now. Determine the equation of G inverse in the form. Remember, how do we get the inverse? We said we are going to write this as y is equal to 5, it's going to be 2x plus 6. Next step, we interchange x and y. We will get x is equal to 2y plus 6. And we will have 2y is equal to x minus 6. This comes this side. Divide both sides by 2, we'll get y is equal to x minus 6 all over 2, which will give us y is equal to half x minus 3. Let's check quickly. We are going to get our equation as such. Interchange x and y, get the equation. So even if you leave your equation as x minus 6 over 2, y equals is still fine. That's our equation. We get our 2 marks there. There we got our 1 mark. We move along. 5.3, determine the coordinates of A. Now, remember, the coordinates of A is the point of intersection of our G of X and our G inverse X. And we are going to use the second method. Remember, they've included our axis of symmetry, y is equal to x, to make our life easy. So we are going to use y is equal to 2x plus 6 and y is equal to x. This is our equation 1. That one is our equation 2. Substitute, we will get our x as negative 6 and our y will also be negative 6, which means the coordinates of A are going to be negative 6, negative 6. We get our 3 marks there. Method, x value, y value, we get our answer there. The length of AB. If you check the coordinates of B, we said 0 and 6. The coordinates of A, we found them as negative 6 and negative 6. We are going to use the distance formula to find the length of AB. Remember, according to our CAPS document and examination guidelines, our topics are interlinked. There is no way you can say, I'm now doing paper 1 only. Concepts of paper 1 are used in paper 2 and concepts of paper 2 are used in paper 1. So the length of AB, we are going to use the distance formula, and you are aware that the distance AB will be given by x at b minus x at a squared plus y at b minus y at a squared under the square root. So ab becomes the square root. Our x at b is going to be 0 minus our coordinates of a, -6. We square that plus our y at b is going to be 6 minus our y at a, which is also -6. We square that. This will give us our answer as -6 and negative 0 minus -6 will give us 6. 6 squared will give us 36 plus 6 minus -6 will give us 12. 12 squared will give us 144. But you are using your calculator, and then you will get this as AB is the square root of 180 in set form. This is going to be 6 root 5 units. We get our full marks there. We got our answer is that. So substitution, answer. Now we move on to activity 2. I am going to give you 6 minutes to answer activity 2. Please read the information carefully before you answer. Welcome back. I hope you have enjoyed answering this question. Typical exam question under inverses of a quadratic function. So we are given a sketch. In most cases, when we are given a sketch, we interpret or determine the equation. That's what will follow. Right. F inverse is also drawn. P is -6 and -12 is a point on F. R is the point on F inverse. Is F inverse a function? Motivate your answer. So that one, you must answer whether it is a function or not using yes, it's a function, or no, it's not a function. So let's check. What would you say? Is F inverse a function? Let me trace it so that you are able to see. F inverse is this red graph that I'm drawing here. Is it a function? Let's check. Horizontal line test, it passes. Vertical line test, it passes. So yes, it is a function. It passes both the vertical line and the horizontal line test. And it is a one-to-one function because it passes both the vertical line test. It is a function. It only intersects. Can you see that the red graph is crossed by the vertical line once? Also for the horizontal, it will only be intersecting at only one point. It is a one-to-one function. It passes both the vertical line test and the horizontal line test. Yes, motivation. We move on to the next one. You can also use the fact that F, which is our original function, it's a one-to-one function. Therefore, F inverse is also going to be a one-to-one function. Remember our axis of symmetry, y is equal to x. If R is the reflection of P in the line y is equal to x, can you see the guidance? Y equal to x, you know that this is our inverse function. Remember, our P was -6 and -12. If this is reflected about the line y is equal to x, it means the coordinates of P are now the coordinates of R. P is on the original function, R is on the inverse function, meaning x and y swap position. So R will have coordinates -12 and -6. You can see that this question is testing us the understanding of the meaning of an inverse function and how it relates our x values on the original function and how they swap position with the y values. So that point, you know that x and y just swap positions. We move on to 4.3. Calculate the value of a. So now our restriction x must be less than 0. We are only dealing with the arm of f, which is concave down, this one here. It says calculate the value of a. So in other words, our f is concave down, meaning our a has to have a negative value. So we are going to use the coordinates of point. So it's f of x is equal to ax squared. And if you check, our f of our x is -6 is equal to a times -6 squared. When our x is -6, our y is -12 is equal to 36a. -6 squared is 36. Our a becomes -12 over 36, and this will be equal to negative, we are able to get that one, -1/3 when we simplify. That's the value of a. Write down the equation of F inverse in the form Y. Remember, this one we are having a restricted domain, so we are going to have Y is equal to, we now have the value of A, negative 1 over 3 x squared. Remember the restriction, our x is less than or equal to 0, and our y is also less than or equal to 0 because our graph is only defined on the negative y values. We interchange x and y, we will get x is equal to negative 1 over 3 y squared, and we divide both sides by negative 1 over 3, we get negative 3x is equal to y squared, and our y squared is equal to plus or minus the square root of negative 3x. Now, because of the restriction, our equation will be y is equal to the plus. It won't work for this quadrant, and we take the equation negative 3x, and the restrictions have to be given there. Our x, whatever was our range, becomes our domain. Our x will be less than or equal to 0, and our y will also be less than or equal to 0. We get our 3 marks there. You are able to see, interchange x and y. We get y squared is equal to negative 3x, y plus minus, then we get also the restriction has to be given for this one, because our x has to be less than or equal to 0. Otherwise, this becomes undefined if we do not include the restriction there. Now, we will stop here for today. I hope you will continue to engage with our inverse functions. Next week, we are continuing. We'll do more problems that involve restrictions as well as our exponential function dealing with the inverse. How do we obtain it, and how do we do the sketching and the interpretation? Now, let's always analyze the information that we are given to determine the type of function that we are working with in order for us to do the correct thing. Information that we deduce should always be linked to the function type that we are dealing with. Domain and range of the as function must be written down to help us find the domain of the inverse. We will discuss more about this one next week. To obtain the inverse, the steps, we remember them. We write it in the form y equals, we swap x and y, and we make y the subject again. And for a function to have an inverse, it has to be a one-to-one function. Remember, for a function to have an inverse, which is also a function, it has to be one-to-one. A quadratic function without a restriction, which is a many-to-one function, its inverse will not be a function. Hence, there is need for us to restrict the domain so that we deal with a one-to-one function so that its inverse is a function. I thank you. Enjoy the rest of your afternoon, and let's continue to practice maths. We see each other next week, same place, same time, so that we are able to work. In the meantime, we have compiled some worksheets from past papers so that you are able to practice. That is the first one, of a linear function with restrictions. We also have a quadratic one where we are going to practice how to answer questions that are based on this. We also have another one there where you are going to determine the equation and answer the remaining questions. We also have that one where we are given the equation. We are supposed to find the equation of k, which is the inverse of h. And then we also do 6.22, the coordinates of the point of intersection. You can see that examiners like these questions. Let's continue to practice. I thank you.